For our last panel this afternoon, for the Joint Standardization Boards, we have Mr. Lloyd Thomas, I believe is with us online, who will be moderating. Lloyd Thomas is both business and finance manager for DSPO, and he also is the program lead for the Joint Standardization Boards program. We see you, Lloyd, up on the big screen.
Hey, Michael.
Moment. I'll turn it over to you.
Okay, sounds good. Can you hear me, Lima Charlie?
Yep, Lima Charlie. Yes.
Okay, great. Quick question. Are the standardization execs still there? I've humbly offered that the most exciting part of the day is about to come. Joint standardization boards, and I don't know if that's because it's the last panel or because it's operational standardization, logistics at work. Actually, I very much enjoyed the other panels today and the standardization execs panel. We greatly appreciate the support and enthusiasm from the execs for standardization. They're the leaders in their services, and we really couldn't do it without their support. Before I begin, I need to give a quick shout out to Greg Saunders, who I've seen on camera, and he looks great in full retirement. Greg was our director for so many years. I think it was before my career began 33 years ago. Good to see you, Greg. I'm sorry I'm only virtual due to a possible COVID infection. And I didn't have to wear my suit, but for the last 30 minutes or so. Anyway, I'm Lloyd Thomas, the program manager for the Joint Standardization Boards, which there are 5. We have 3 here today presenting. I also do the budget execution and programming for DSPO. Congrats to the DSP award winners. I'll be sending that $5,000 to the Navy, and just so you know, it gets divided among the team. And I'm real sorry to Dr. Jensen. There were a few years that we did not give out the cash awards due to various reasons, budget and otherwise. But okay, so joint standardization boards, excuse me. They're about systems and equipment that apply to the joint force and require standardization or interoperability. You've heard about both of those, throughout the day, a lot about interoperability. So today with our panel, we'll describe what a JSB is, what JSBs currently exist, and some key players, what they do, what they work on, some issuances or documents that are involved, and what products they've developed or successes they've had. Today you'll hear from these 3. Expeditionary Shelters and Basin Equipment, ESB, and the Aerial Refueling JSB, which is also known as RSAG, Aerial Refueling Systems Advisory Group. And in fact, if you may have heard Dr. Honey refer to RSAG this morning as our keynote speaker, mentioning the drone refueling. You'll actually hear more about unmanned aerial refueling when Mr. Farhad Choudhury speaks on the MQ-25 aircraft. And then the third and final presentation will be by 2 folks from the on the Fuze Initiation Systems JSB. That's represented by the Fuze Engineering Standardization Working Group. And so just to give you a little bit of information, and then I'm going to turn this over to our first panelist. The JSBs are, like for instance, today you're going to hear from the Fuze Initiation Systems, and you'll see that they have many standards and many STANAG, standardization agreements, NATO agreements, and other documents they create and maintain. RSAG as well has many STANAGs and standardization agreements and standards that they maintain, and other recommendation documents related to aerial refueling. You'll hear about tactical shelters, what was once called the Joint Committee on Tactical Shelters, JCOTUS, its history and how we grew that JSB to include basing equipment, bringing in more influence from the Air Force, and continually working to improve standardization and using standard sets or products. So the other 2 JSBs not shown here on the chart are the mobile electric power systems, generators, and power source systems, batteries, JSBs. I have a little information I'll share about that maybe later. So what is a JSB? Keyword joint, multi-service at a minimum or multinational in the case of aerial refueling and fuses. JSBs, pretty much typically all of them began as a technical working group, and they still exist as a technical working group with their own internal charter. But they became recognized and chartered as a joint standardization board by the Defense Standardization Executive. And it's something our office staffs up through the executive. And that promotes membership, it promotes willingness to spend travel funds to get folks together and solve problems. And keywords here is standardization and interoperability. I already said that. Of course, standardization encompasses interoperability, even though that's a big one. Interoperability is a big one. They all began as a coalition of the willing from that technical working group. And we have the MEPS, Mobile Electric Power Systems JSB, that actually has codified the JSB participation and concept as a requirement in its redrafted instruction, DODI 4120.11, Mobile Electric Power Systems. Now, if you notice that sequence, 4120, is our same sequence for the DSP, Defense Standardization Program Instruction 4120.24. And so they picked that sequence and maintained with that, even though there was some discussion, just because that's how much importance they put on standardization. There have been many times generators who just went rampant across the services, and it's just very hard to maintain logistics on them. And so MEPS is similar to SB, if you will, which you'll hear about here in just a minute. As far as we have a standard set, we have a catalog, and we encourage participation in using those standard sets to improve standardization and interoperability. So a couple of more technical definitions. A JSB specializes in a certain area, but it may typically cover multiple federal supply classes or federal supply groups or standardization areas. It's always provides a DoD-wide forum for achieving standardization solutions, promoting interoperability, and often discussing specific joint service acquisition and logistics requirements. A lot of times folks get together and talk about specific things they need to buy. And so, and typically JSBs can't be handled by a single lead standardization activity. That's terminology in the standardization community. They may cover evolving technology, or they may cover a commodity with no lead standardization activity. So please allow me to introduce and give a little background, or a bio background on our first speaker. Representing the Expeditionary Shelters and Basing Equipment SBJSB is Ms. Connie Miles-Patrick. She is the team leader for the System Development and Engineering Team, Engineered Systems Division, Soldier Sustainment Directorate at the Combat Capabilities Development Command, Soldier Center in Natick, Massachusetts. There they provide soldiers with body armor, uniforms, food, and shelters, and much more. She and her team are responsible for the research, development, and engineering of mission command platforms and deception assets for the U.S. Army. Ms. Miles-Patrick has over 30 years government service with more than 20 years as a project engineer focused on shelters, shelter integration, and shelter transportability certification program, where she is the code lead. The SBJSB is the only JSB chaired by the director of DSPO, Michael Hafey. And Ms. Miles-Patrick's office serves as the executive secretary of the JSB. And JSB has over 100 volunteers from across DoD who are experts in expeditionary shelters and basing equipment. Ms. Miles-Patrick earned her Bachelor of Science degree in Industrial Engineering from the University of Alabama, Roll Tide, and Master of Science degree in Engineering Management from Northeastern University, and a Master of Science degree in Engineering and Program Management at the Naval Postgraduate School. She is also a recipient of the Superior Civilian Service Award for her duties during Operation Joint Endeavor Joint Guard. Please help me welcome Ms. Connie Miles-Patrick.
Thank you for that very good introduction. Actually, Lloyd gave a few of my points that I was going to talk about. But I do want to thank the Defense Standardization Office for inviting me to give an update. Lloyd, I've worked with you for a long time, and it's very nice to meet Michael for the first time. I've seen him online. I've corresponded via email, but I've never seen you before. So it was nice to shake your hand. Um, it always amazes me when I think about how long I've been involved with Jacodis and JESB. It's actually over 25 years, and actually it's about 30 years. First as a young engineer when it was just the right thing to do. It was in the area, so it's like you need to attend. And then I like to say that I drank the Kool-Aid. I got on board. Um, I started believing in what it stood for, the reduction of duplication, safe standard shelters in the field, as well as finally the camaraderie between the shelter community. Next slide, please. So, yes, I'm sorry. Okay. Oh, all right. Is this better? Okay. I thought about that when everybody else was talking. I said, I'm not going to make that mistake. And I made that mistake. Um, so it surprises me when I was thinking about this that I didn't put a single picture in this presentation. So Lloyd, thank you for having that picture on the top. I think it was the right or left, I'm not really sure. It basically showed PMFSS force provider system, and it had a combination of both soft and rigid wall shelters. So even though you couldn't see it that clearly, it showed different shelters that we have. When most people hear or think about shelters, they think about soft wall tents. But actually, the Jacodis started with rigid wall shelters. Um, that was, and so shelters are defined basically as something to protect our troops, our weapons, our equipment, cargo from change in climates. But it's more than that. Our shelters are used for command centers, for maintenance shops, for medical facilities, for operating rooms, for billets, kitchens, anything that goes on the back of a deuce and a half or 5 ton. Normally, if you see a box on the back of a truck, that's a shelter. You see them on Humvees, as well as on the soft shelters as well, the tents. One of the problems or reoccurring problems that we have just in general is that a lot of the PMs out there have these really great systems and they think about it, does really great thing, and then an afterthought is, well, what am I going to put it in? Or how am I going to transport it? That's when they normally think about a shelter. And the thing is we want it to be safe. I said that we want it to be sustainable. We want it to be able to get your item out into the field and be sustainable. And normally it's an afterthought. So I'm not 100% sure why Jacodis started in 1975, but based on some of the history that I heard this morning, um, it probably started because we wanted a standard item. And in a later slide, it will say that when it started, it actually had 100 rigid wall shelters out there, and then it reduced down to 25. So I'm getting ahead of myself, but I did want to show this timeline that the Joint Committee of Tactical Shelters started in 1975. Almost 20 years later is when it encompassed soft shelters or tents. In 2009 is when we started including shelter technologies, lights. We want to make the material lighter. Um, Basically, as the doctor was saying, I forgot your name, it's like we've had the same technology for so long. It's like we wanted to improve that technology. And so we made an emphasis of including that in 2009. I'm going to jump to 2017 when Lloyd kind of mentioned, we combined JESB with the Joint Equipment Basing Working Group. Probably about 2016, the the they met. And so they did everything other than shelters and generators. So they talked about the lights, the water bladders, everything else that went into a command post. And then the next day we had our Jacodis meeting. and probably about 80% of those same people just transitioned to the next meeting. So why not combined? And that's when in 2018, we became the Joint Standardization Board for Expeditionary Shelters and Basing Equipment so that we're all together. Lloyd also implied that, well, one of the things that Lloyd says a lot is the coalition of the willing, and so sometimes people would show up or different services and they would show up almost not quite because they had to, because they wanted to, but they almost didn't want to play together. And after showing up and finding out that the benefits of doing contracts together, talking about your problems and trying to solve problems, we started becoming a better functioning group. And so I'm not going to say which service it was that was kind of holding out, but now we all play together. And what's not on the chart is in 2020, we went from my favorite paper catalog, which is the Dakotas, and it basically lists all of our shelters from all the different services. And I'm old school, so I like paper, but I am very happy to say that it's now electronic. And I want to thank again the Defense Standardization Program because they helped us to transition that, and it's actually on their website. So next slide, please. So a little bit to repeat myself, but once again, in 1975, JES JACOTUS was formed under the Office of Secretary of Defense. You can see the bullets, but basically we wanted a safe item. We wanted it to be able to be transported and used safely by ground. It's transported by rail, by air. We wanted to reduce the number of non-standard shelters that was in the field and maximize the standardization of shelters. Next slide. As I said earlier, when they started this, in our history, we talk about it was over 100 shelters out there. So not just the problem of having 100 shelters, you have this huge logistics burden that you have to deal with. Next slide. So the outcome of the initial part of JACOTUS was that 100 plus shelters reduced down to 25, which it definitely reduced the logistic burden. We have all the services working together. And I like the term, I wrote it differently, but somebody talked about the inoperability or be able to operate together. So sometimes you can't get all the shelters. You can't get the Air Force to buy an Army shelter because of whatever reason, but you wanted to be able to hook up to the ECUs to be able to hook up together or the lights. So if you have a problem, you can have one service to use or to utilize a different aspect from a different service. So we definitely do that. The next slide, please. So I like to use the word standard all the time. So what does a standard shelter mean? So you can see the bullets, but basically safe. It's undergone testing. You have a technical data package. You have the manual. It's a part of the total life cycle management. You have a sustainment command and primary inventory control. And the last part is the transportability certification if needed. And that's a little different. So once you have a shelter, so the plain box is what you received when you buy it, and then you integrate it. So then it's not just that the box is safe. You want to make sure that you can transport it from one point to the other. So as a young engineer, when I was testing more, I would love for the integration of, especially when it wasn't my item. So someone would integrate the shelter, they put their lights, their command post or maintenance shop, and then we'll do the test for it. So it has a battery of tests. So you have to go through ground, and this isn't through highway, this is off road. You do rail impact when it has to be hit 4, 6, 8 miles an hour, then reverse it and hit again. Might have to drop it. And so you want to make sure that your equipment can sustain all these tests. You want to make sure that it gets from point A to point B. And so if you integrate it after the fact, you have to go through this. And if it wasn't my item and there was a little bit of damage inside, I was like, yay. But once again, if it wasn't my item, when it was my item, you call back because normally the test took place at the Aberdeen Proving Ground. You call back and you try and figure it out, try to to get it fixed. You get somebody who knows how to, fix it, flown down really quickly. But the main point is this is what we call a standard shelter. Next slide. So, what does Jacotus look like today? What is our mission? Um, we have over 100 volunteers, as Lloyd likes to say, the Coalition of the Willing, that participates. We are the experts um, that provide information to the service headquarters and joint staff for all matters related to the engineer. Sorry, that's how to the expeditionary shelters and basing equipment. With that, so overall, it's like some people said earlier. It's nice to be face to face, and I agree with that. It's good to see people, to meet people. But one thing about COVID is that you have more people that could dial in. I don't know how many people are online, but not everybody could travel for various reasons. So our our database of people from all four services is over 100, and our at least two meetings, I think it was 3 meetings during that time, we would have 80 plus people online. Normally, when we meet face to face, we have about 30, which is also a good number. One of the things that we do is that we meet twice a year, and I said over 20 years. So, if I'm honest with myself, I've been involved with this organization for over 30 years. So we've been meeting twice a year for at least 30 years, and I don't know before when it first started in 1975. Um, During these meetings, we do the business of JESB. So we talk about any actions items that we have. We talk about testing. We try to work together when we're doing testing of items for different services to work together. We share tests or exercise results. So we have presentations on that. We also meet in different locations. So one of the things I thought about was the person who presented on corrosion. So back in the beginning of time when I first started, we focused a lot on corrosions. And then we shifted to composite materials. Now we're doing a lot of focus on Arctic and how both the rigid and the soft wall shelters are performing in that environment. So we're looking at negative 65 degrees. Back in November of 21, we had an opportunity to go to Alaska, Fort Wainwright, to have our meeting. So we could actually talk to the engineers and the SMEs in that environment about our items. And it wasn't just shelters. We had to talk about water bladders and just a whole list of things. And we had an opportunity to go to the permafrost tunnel, which is run by Corel. And if you ever have an opportunity to go, you should go. It's not open all the time, so you have to make arrangements and go through the Corps of Engineers. But it's been around since 1963. Most of the tunnel was dug by hand, but you can see the permafrost. That's the main point. So when you put a shelter, when you erect one in that cold environment, you have to worry about melting. You have to worry about the freeze, the melt, and the refreeze of an item. So if you put a rigid wall item out there, then it will probably collapse. They actually had us go through a community with houses was built incorrectly, and you can see how the houses are crumbling. And I share about that because we go different places for our meetings so that it's not just the Army and what our concerns are. It's not just the Air Force or the Navy. So our next meeting will be actually in Fort Hueneme. I wanted to make sure I try to pronounce it correctly. Fort Hueneme in November. So we'll talk about the regular business of our business, but we'll see what their concerns are in the shelters and anything else they want to show us. So I do like the road trips, similar to the gentleman that was talking about going to all of his different meetings all over the world. We don't go all over the world, but I do like being able to visit different bases, talk to different SMEs about how their shelters and items function in the field. And we still have the two fundamental functions of minimizing duplication, making sure that we have a safe item in the field. Next slide, please. Thank you. So as Lloyd said, um, Michael is our chairperson. Lloyd is his action item, his action officer. The executive secretary is my boss, Mr. Rich Benning. He's acting right now. And I am the executive, his action officer. We have voting members from each of the four services, and then off branches from that. We have working groups as needed. For a long time, it was rigid wall or soft wall. And now it really just depends on what's going on. We're also looking at trying to get a QPL list for rigid wall shelters. And so that's one of the working groups that we have now. And we have just general participation from just all of the services. When I first started, most of our members were Army, and now we're trending Air Force. I'm not sure what changed, but Air Force outnumbers us almost 2-to-1 at the meetings. And then, like I said, we still have Marines and the Navy. So where are we going from here? So part of me wants to kind of summarize and say we're going to keep doing what we're doing. I think that we're doing some great things. We're going to continue having our biannual meetings. We're going to continue to figure out what our problems are. If one service is having a problem, more than likely that problem is going to transfer eventually to the different services. We're going to continue to foster collaborations. We talk about the contracts that one service is having versus another, so that we can try to buy items off of that contract. Test any evaluations, any exercises that one service is having. We want to try to open it up or make sure that it can be opened up so that another service could send their item as well. Try to minimize costs. And like I said, trying to solve a problem before it becomes a problem for everyone. When we started, we actually had a DODD, this 4500.37, which is now inactive. So we're also starting a new initiative to try to get a DODI, so that we can have a little bit more teeth in our organization. And then we basically just to look at our RDT&E programs in general, modernization of our current joint service fleet, take advantage of any commercial technologies. We talked about that today. And just maintain the relevance to our users. That's all. So I think we'll probably ask questions at the end, but like I said, we've been around for a while. Our main point is trying to get a safe item into the field and a standard item. That's it.
Very good. That was great, Connie. Thank you. I just wanted to make a few little notes here that it was in 1975 when JACOTUS was formed. This was after we were coming out of Vietnam. There was a huge, as you mentioned, logistics burden with all these shelters, and there was no standardization at all. And so that's when the JACOTUS group was formed. And then it even included sharing of RDT&E budgets to get better shelters. And then when we added basing to shelters, it really was some of that largely in response to the DoD instruction or DoD directive, rather 3000.10, which was contingency basing outside the U.S. And that was a way to begin that process. That's a much bigger animal than ESB is, but anyway. And then the JEBWIG, Joint Expeditionary Basing Working Group, was largely Air Force, and so that's why I didn't realize it was 2-to-1 Air Force over Army now, but because it was a huge Army membership versus Air Force, and now it's kind of flipped. So very interesting. Thank you so much, Connie. Okay, so representing the Aerial Refueling Systems Advisory Group at what we call the Aerial Refueling JSB is the chair, Mr. Farhad Choudhury. He is from the Naval Air Systems Command, NAVAIR, at Lakehurst, New Jersey, where he began his career in September 1986. For the first 7 years, he worked as a project engineer in the propulsion division of the aircraft ground support equipment, and then worked in design and development of depot-level aircraft structural repair equipment. From 93 to 2007, he transferred to and worked in the Air Vehicle Engineering Department, and in 99 became the Class Desk Lead Systems Engineer for Navy's Aerial Refueling Program. Mr. Choudhury moved on to the program office at NAVAIR in 2007, serving as the Deputy IPT Lead, and then since 2013 as the Program Manager and IPT Lead for the Navy's Aerial Refueling Program. He manages a team of engineers, scientists, and logisticians spread out throughout CONUS at various NAVAIR sites, and he manages a budget of approximately $20 million in procurement, sustainment, and development funds. He is currently the chair of RSAG, or the JSB for Air Refueling, and he also chairs RSAG's Advanced Concepts panel. In these two capacities, he works with representatives from U.S. Air Force, Transcom, Ministries of Defense, industry, NATO Air Forces, NATO's air refueling panel, and in the development of air refueling guidance documents and revision of air refueling related specifications. One thing very interesting about RSAG I'll add in here is that nowhere else you'll go and you'll meet and you'll sit down with the Navy and the Air Force, Boeing, Airbus, and Lockheed all in the same room working on same problems. It's pretty amazing. But born in Bangladesh, Mr. Choudhury immigrated to the United States in 1971. He graduated from the City University of New York with a Bachelor of Science in Mechanical Engineering in May of '86, and he has been selected and inducted as a NAVAIR Associate Fellow. He's a graduate of the DoD Executive Leadership Development Program and a recipient of the 2011 NAVAIR Commanders Award and the 2008, 2016, 2022 RSAG International Awards. And he is Wheel Level 3 certified in both system engineering and program management, and a member of the Department of Navy's acquisitional professional community. Without further ado, please welcome Farhad Choudhury.
Thank you, Lloyd, for that. All the kind words. I didn't think you're going to read the whole thing, but okay. Thank you so much. Thank you, everyone. Again, as Lloyd said, Farhad Choudhury from NAVAIR. So my office officially is Patuxent River in Maryland, but I sit at Joint Base McGuire-Dix Lakehurst. I see a couple of my cohorts in the audience. Good to see you. So I know you've all had a long day, so I can really make it short and say standardization saves lives in aerial refueling business. Thank you for inviting me. Have a good day. Or I can go into it a little bit more and say that anytime we put two planes together for refueling, it's inherently dangerous. And it's dangerous in the daytime. So think about doing it at nighttime. Think about doing it in bad weather, turbulence. It is extremely dangerous. If we are driving on a highway and a car comes too close, we report it as aggressive driving. 18-wheeler, tractor trailer, you can imagine, when you're close, it's inherently dangerous. So standardization, as I said, I believe we need to do that. It does save lives. A year ago, when I gave the brief virtually, I talked about an accident that happened in the West Coast. Two planes collided. That's a very bad day. So refueling happens successfully hundreds of times a day. It's obviously it's the pilots, it's the tanker pilots, the receiver pilots, but there's a lot of standardization work that's done behind the scenes by a lot of folks, and I'll talk about that. So next slide, please. Here we have a very pretty picture of a F-18 Super Hornet with the hose extended out with the drogue basket hanging out at the end. This is the way Navy and Marine Corps and a lot of the NATO countries, we do business called the probe drogue refueling method. Air Force does the boom receptacle method because their planes are a lot bigger. The receivers are a lot bigger. They're bombers, higher pressures, higher flow rates and all that. So Navy is different, much smaller planes, fighters. So this is a organic tanker, carrier-based. So right off the bat, I'll point out a couple of things. I don't know if you can see it very clearly. We need to worry about NVG compatibility of the basket that's hanging out there that you see lit up at the end. There's also hose markings that we need to worry about. There you might see black and white stripes on the hose. So those are just a couple of examples. The angle of the hose coming out the airplane is what's known as catenaries, and that's important. I'll get into that a couple of slides from now. So, and also the drogue itself has canopies that we had to modify the drag values of the canopy. That determines how high or low that drogue will fly coming out of the F-18. So F-18 is our bread and butter tanker on the carrier, as I said. During Operation Enduring Freedom, Navy got there first with their carriers, and we had to wait for our coalition partners, NATO partners, Air Force, to gain permission to come to nearby countries to support missions, strike missions. So Navy was doing business with Navy's own tankers until we got our Air Force and NATO tankers there. So a lot of bad things can happen. And as a matter of fact, last Tuesday, we had a refueling incident where the receiver came up on that drogue basket, didn't plug correctly. We don't know the details yet, if it was too fast or off-centered. So metal pieces would fly off the drogue basket and got sucked into the receiver's engine. It was an F-18, 2 engines, so flamed out 1 engine. It was close to a base, so recovered safely, no issues. But imagine if we were in the middle of an ocean, no nearby bases. And up until recently, Navy had dual engine airplanes, A6, EA6B Prowlers, F-14, F-18s, and all the variants of F-18s dual engine. I said up until recently. So now we're getting the F-35s, single engine. And so we'll talk about that. So anyway, next slide, please. Here we have another pretty picture of an F-18 out of Patuxent River refueling an E-2D Hawkeye. And this requirement came out of Operation Enduring Freedom, and it was determined that if the E-2 can loiter around, if they were refuelable, they could do their mission a lot longer. So starts the engineering, computational analysis, and modeling and all that. And so it looks easy on paper, but we ran into some issues. So the E-2 program office modified an airplane with the refueling probe, plumbing, and all that. And next slide, please. So as I said, we ran into some issues. The catenary, the hose angle, and where it plugs, the jet exhaust out of the F-18 was causing a lot of issues on the E-2D rotor dome. So a lot of options were put on the table. We talked about that. Right now, we have a conditional flight clearance for the E-2Ds to refuel behind an F-18. However, you have to inspect it for so many hours and all that to look at the damages, possible damages that you might do to the receiver. So one of the options we're looking at right now is possibly for a longer hose. I'm not a pilot by any means, but I play one in the conference, so I'll play one. So sorry for the folks that are virtual. So with the longer hose, the E2 and in the back, E2 would want to plug, and hopefully it'll give them a little bit of clearance away from the jet exhaust. So that's what they're looking at. Again, we're looking at the engineering studies. We're trying to see if that's an option to go with a longer hose. So again, standardization. Next slide. Another pretty picture of a Air Force KC-10, and we have an F-35 coming up behind the KC-10. So F-35, Marine Corps Navies have the probe. So that's what we're looking at here is a Navy F-35. And Air Force tankers, obviously, as I said, they have the boom receptacle system, but they also have provisions to refuel Navy Marine Corps probe-equipped receivers. Again, seems like it's doable. We have the hose extended out of a KC-10. Here comes an F-35. Next slide, please. Successful plug. So we found out the light that you see on the F-35, was blinding the KC-10 boom operator. So lost situational awareness, had to go back and change out the light angles, wattage of the lights, different types of light, LED versus. So we went back, we retested, and we now have a different, again, standardized lighting. So next slide, please. Here we have the MQ-25, our future. This is going to be a tanker with IOC of 2025. So this is going to be unmanned and operating out of carriers. On your right-hand side bottom, that talks about a few of the missions. So primarily, it's going to be a tanker. It's going to have other missions like ISR, things like that, and working off of the Nimitz class carriers as well as the Du4 class carriers. And next slide, please. Again, MQ-25 talks about some of the capabilities, missions, that sort of thing. You'll have this in your package. I won't go into too much. So currently the F-18 carries the buddy store, the refueling pod center line. The MQ-25 will carry it under the left wing, as shown in the slide. Next slide, please. And I apologize if I'm going too fast. T1 is an MQ-25 asset owned by Boeing, and they did a lot of validation of tanker capabilities, host extend, retract, flying qualities, if you will, and then eventually it plugged F-18, as you see, top picture, bottom picture, MQ-25 refueling in E2D. Again, this is a Boeing asset, so we haven't received our Navy assets yet for testing at Pax River to make it go through our valves and all that. So next slide, please. And here's another pretty picture. Future of the Navy, unmanned MQ-25, and here we have an F-35 Charlie. F-35 just came back from a deployment from a full deployment with an F-35 Charlie, and we have an F-35 Charlie Marine Corps squadron that's deployed on the carrier as we speak. Next slide. So RSAG, Area Refueling Systems Advisory Group, charter is a JSB, as Lloyd mentioned. Have been doing this for a couple of decades now, and I'm serving as the FY22, FY23 chair. I rotate out with my Air Force counterpart, and he serves as the chair. I serve as a deputy. So right now, we've been doing this, rotating every 2 years, and it's been working well for us for continuity purposes. Next slide. Again, as I mentioned, RSAG is a JSB. We meet also twice a year, face-to-face, except for the last couple of years. We've been doing it virtually. But the work, besides the face-to-face meeting, work goes on throughout the year. And that's each up to the different groups that I'll talk about in just a second. What we provide, what RSAG JSB provide is recommendations and guidances. So we have documents that we produce, and we'll talk about that, available to DoD, NATO coalition countries. Next slide. These are the 7 groups under the RSAG JSB. Boom receptacle, as I mentioned, Air Force type refueling, probe drogue, Navy, Marine Corps type refueling. I touched on the hose markings, lightings, which is the formation aids, markings, lighting group. There's also the maintenance support equipment group. There's the clearance process, why that's important. Many of the countries are getting new tankers, new receivers. They want to make sure their tankers can refuel our receivers, vice versa. We have the KC-46 Air Force receiver tanker. We want to make sure that NATO receivers can refuel behind the KC-46 as well as our Navy Marine Corps receivers. Systems requirements verification methods, and also the automated aerial refueling group, which is mostly about unmanned systems and automatic autonomous refueling. Next slide. So RSAG has been around since 1978. We've been chartered as JSB. probably 10, 12 years after that. So we produce, as I mentioned, recommendations, guidance documents, and excuse me, NATO has looked at a lot of our documents, JSV documents, and they've provided SRDs and STAINAGs out of our documents that we produce. Next slide. So I won't bore you with how we produce a document, but again, Lloyd talked about we are DoD, NATO, service engineering folks, service folks, as well as industry subject matter experts that get together. We talk about, hey, wouldn't it be great if we work on this topic? And that shows you the process of what happens after that, how a project gets initiated and what the flow through is. Next slide, please. Thank you. So we'll go through, look at it, whether it's validity, whether it's aligned to what we want to do, whether it, falls under JSB, and we will assign a group that we believe is the best suited to work on that particular project. We have an independent document review team, DRT, otherwise known as a DIRT team, and again, independent from JSB. And finally, next slide, please. It'll get to executive director and on to me, and also to my counterpart in the Air Force, and our signatures, and then we provide it to DTIC, make it available for everyone to work on. And so thank you. So these are, this is a list of all the completed documents that we have by document numbers available in DTIC. Won't bore you by going through all of them. Next slide, please. So again, this and the next slide is our current list of documents that we're working on, and 7 groups are working on this. Each group has folks from Army, we have 1 or 2 reps, Air Force, Navy, Boeing, Lockheed, Airbus, and also the NATO Air Forces that we talked about. They all get together and work on these documents because we feel coalition of the willing, as we talked about. We believe in this process, interoperability, obviously safety that we talked about, because accidents do happen, and we want to reduce that as much as possible. So next slide, please. So the future of RSAG, obviously, the documents we showed previously, last couple of slides, we want to work on those documents, complete those documents. I mentioned new tankers, new receivers that are coming out. We want to make sure that they can plug and play, if you will, up at 30, 40,000 feet in the air. It's important because we live, as everyone's aware, in a very dangerous world that we're living in, and refueling would get our tactical fighters, bombers to their destinations, and that's how we get them to their destinations is by refueling. So the future is going to be unmanned, and how do we do that? Because pilots inherently, a tanker pilot, for example, would know that my system is working by noise, vibration, hose goes dead, and someone plugs. So a pilot would know to do emergency breakaway, retract the hose, or what have you. When we have unmanned systems, we don't have a man or a woman in the loop. So there's a ground station that the ground operators are working on with flying the unmanned vehicle. So it's going to be learning as we go along. So stand by, and hope to come here a year or 2, 3 from now and tell you how it's going, hopefully, or somebody from the Navy or Marine Corps will. If I'm not here, but somebody from my office will. So it's a very interesting future. We're going to have a unmanned tanker refueling manned receivers. I can also tell you that we are also working on unmanned tanker to unmanned receivers, and that's not too very far off either. So we're working on that as we speak. And with that, again, I think we'll take questions at the end of our next presenter. So over to you. And to Lloyd for the introduction.
All right. That's great. Thank you so much, Farhad. That was wonderful. I'll just make a quick comment. RSAC does an annual meeting. It's really like a large conference, and it's pretty much remarkable and fantastic. If anybody has any interest in standardization and fuel or refueling or aviation, some of the things that they discuss and put up and displays is really interesting, and it's from around the world. It's around NATO. So, Farhad, how many nations would you say are there typically?
25 plus.
Yeah, so almost full NATO package, and then some non-NATOs. But anyway, so it's fantastic, Tom. So thank you very much. So last but not least, certainly not least, is our Fuze and Initiation Systems Joint Standardization Board. I will go back and forth. It's also called, they're represented by the Fuze Engineering Standardization Working Group. Been around a very long time, and Sandy will tell you more about that. But we have two speakers. One of you whom is there with you, Sandy Picinic, and the other who is virtual, like me. I'll introduce both now. As I said, first is Miss Sandy Picinic. She is an area manager in the Army Army Fuze Management Office at U.S. Army Combat Capabilities Development Command Armament Center. Ms. Picnic's government service began at Picinic Arsenal in New Jersey in 2004, working in the System Safety Office, where she worked approximately 9 years before moving to the Office of the Director of Technology, executing the Armament Center Science and Technology portfolio. Since 2013, Ms. Picinic has worked in the Army Fuze Management Office, serving as the Army Fuze Safety Review Board, Executive Secretary, and Army Technical Advisor to the Joint Standardization Board for Fuze Initiation Systems. Ms. Picinic has both a Bachelor of Engineering and a Master of Engineering in Mechanical Engineering from Stevens Institute of Technology. And the second speaker is Mr. Anthony DiGiacomo, and he's also an area manager in the Army Fuze Management Office at U.S. Army Combat Capabilities Development Command Armament Center. He began his civil service at Picinic Arsenal in 2005, working on artillery and hand grenade fuses in the Fuze Division. In 2008, he moved to his current position, where his responsibilities include oversight of ammunition fusing and for tanks and hand grenades. And he's also the chairman of the NATO Standardization Group on Fusing and Initiation Systems and the custodian of several FESWIG documents. He's an advisor to the Army Fuze Safety Review Board and a member of the Army Material Release Review Board. Prior to joining Picinic Arsenal, Mr. DiGiacomo spent 25 years in private industry, working for various aerospace and defense companies on electromechanical actuation systems, including a role as vice president of motion control systems. He received his Bachelor of Engineering in Mechanical Engineering from the City College of New York and a master's degree in Technology Management from Stevens Institute of Technology. Folks, please help me welcome first Ms. Sandy Picinic. Thank you.
Thank you. And thank you, Lloyd, and thank you to DSP office for inviting us here. And so, at least for today, there's some good news and bad news. Good news is we are the last speaker for today. But the bad news is I don't have awesome photos in our previous presentation, but we do have a few. So, but again, I do want to thank Lloyd and DSP for including us and letting us voice the hard work that FESWIG has done throughout the year. So next slide, please. So here is agenda, a few of the topics we're going to go through. So we're just going to touch a little bit on FESWIG, what Fuze and Initiation Systems are, why they're so critical in our DoD munitions. We'll talk a little bit about the office that I'm from, Army Fuze Management Office, and we'll talk about our existing FESWIG standards and our progress with some of our key documents going forward. And then Mr. DiGiacomo, he'll take over on the presentation when we begin talking to the NATO standardization element of this Joint Standardization Board. Next slide, please. So, so the Joint Standardization Board for, for Fuze and Initiation Systems, we're actually one of the oldest boards on this panel here. We actually have documented our second meeting that occurred back in September of 1972. So we are one of the oldest boards in existence, at least on this panel here. But the Joint Standardization Board under the DSB recognized that Fuze and Initiation System was across the DoD munitions element a key standardization working group. So we go by the acronym of FESWIG, which is the Fuze Engineering Standardization Working Group. And that FESWIG element has two components to it. It addresses both US and NATO standards for standards in terms of safety and inoperability for Fuze and initiation systems. One of the key points that is critical here is that it's well represented. We have members across the tri-service, as well as members from industry and academia who are supporting both these elements. Next slide, please. And so I mentioned before, FESWIG, we have a very long history. We've been operating for over 50 years. In 2003, so I'll go through a few specific milestones. In 2003, we were formally chartered under DoD standardization. In 2006, we formally became a joint standardization board. And we actually held our 100th meeting back in February 2020, right before the onstart of COVID. So that was a major milestone for the working group. Again, as I mentioned, our FESWIG membership, it's well diverse. It's chaired by the Army, by the Office Army Fuze Management Office, and I'll talk a little bit why that's such a good relationship on why we charter or we chair the FESWIG. But our membership is really well balanced and diverse. We have a chairman, we have an executive secretary, and we have representative tri-service Fuze and initiation system members. We also have members coming from our national labs, as well as subject matter experts, and as well as industry and academia. And again, FESWIG, we really serve as the U.S. body for Fuze and initiation system standardization efforts. We do across the board U.S. documents as well as NATO documents as they relate to Fuze and initiation systems. We review and standards new technologies for safety. And we interact heavily with industry for their feedback and understanding on these standards. And FESWIG meets twice a year with ad hoc sessions as needed. Next slide, please. So here's my chart on some pretty pictures, but you can see here, Fuze and initiation systems are key elements within DoD munitions, and they're across the board, across different platforms, whether they're gun launched, ground launched, or air launched. So we have a plethora of Fuze and initiation systems across DoD munitions, and they're really the key technologies for ensuring from a munition standard for safety, effectiveness, versatility, and by far operational efficiency. So they're key elements within the DoD munitions. Next slide, please. So what are fuses and initiation systems, and how does the technical community distinguish between those two? Fuse or fusing systems are really a physical system that are designed to sense a specific target or condition, and they're intended to initiate a train or detonate the munitions final warhead payload. An initiation system, that's a little bit more broad-based, but that's a physical system that's used to initiate an explosive train within of a component within the munition. So certain subcategories of that would be ignition system, which is used to initiate a rocket motor for some of our missiles and rocket systems. Next slide, please. Now, under the Joint Standardization Boards for Fuze and Initiation Systems, we have two elements, one for DoD base, which FESWIC satisfies, and that is the Safety and Interoperability Standards Authority for DoD. It is chaired by the Army Fuze Management Office, and its membership is well balanced among the tri-services. Its complement on the NATO side is satisfied under AC 326, Subgroup A, Initiation Systems Team, and that is the Fuze and Initiation Systems Safety and Interoperability Group for NATO. It's also similarly chaired by Army Fuze Management Office, and that's a key element because that's the tie to ensuring both on the U.S. and NATO standards that we do have commonality and interoperability among our standards. And that membership is well balanced. Not only do we have U.S. membership, but we have NATO countries, partners for peace nations also supporting, and also other elements of NATO as required. Next slide, please. And so just to touch a little bit on the Army Fuze Management Office. So our mission from our office to provide centralized oversight management of all non-nuclear Army fusing systems. So if you look at this chart, we have three pillars. As a core pillar is the Joint Standardization Board Fuze and Initiation Systems effort. One of our other pillars is our involvement on Fuze and munitions industrial base. So we're actively involved with the early on industrial base, early 6.1, 6.2 base technologies that are coming forward for enhancing munition development. And so we're a key partner there, understanding what those new emerging technologies may be. And how does that ultimately affect or impact our current standardization documents related to Fuze and initiation systems? On the right, sorry. So on the right hand, it's a little reverse for me here. So on the right hand side, we have our third pillar for Fuze Safety Board. And that's another key element of what Army Fuze Management Office does. And we chair and we manage the Army Fuze Safety Review Board, which is an independent Fuze design safety board that evaluates munitions design, or Fuze's design criteria. We also help to facilitate, not only as part of the Army Fuze board, but we always invite, and we invite our joint services counterparts to the table as part of those reviews. So we invite our Navy counterparts, our Air Force counterparts, so that we always have a joint services Fuze safety review board. And that's one of our key milestones here as it relates to joint standardization efforts, because we get to review these standards in terms of design compliance, and then we take those lessons learned and we provide that input back into the joint standardization boards as we update and continuously improve our standardization documents. So those three pillars really work hand in hand. We understand emerging technology. We understand how our industrial partners, how they interpret our standards, and where we might have made some miscommunication, misunderstanding. We can bring that to the table back to FESWIG, and continuously update and improve our standards. Next slide, please. So this is our current list on the DoD FESWIG on the U.S. side of Fuze and initiation system standards. So it's a long list of key safety design requirements, key interoperability requirements, and as always, new emerging standards in development. Next slide, please. And so in the next two slides, I'll talk to 5 key documents that the FESWIG is currently working towards, and these are, on a side note, I'm going to emphasize, these are key contenders for next year's award recipients. So just keep that in mind. So our first one, Mill Standard 1901, Revision B, that is our design safety criteria for ignition systems for rocket motors. There's been some significant changes. Currently, right now, we have Revision A. Revision A has been out for about 25 years, so we do have a lot of, there's been a lot of work updating the document. So there have been some significant changes to the base document definitions, inclusion of multi-stage rocket motors, and qualification requirements. Another update is Mill Standard 1316. Revision F was released back in 2017, but there are some changes that are occurring to keep lockstep with the changes that are occurring in Mill Standard 1901. So initiation systems, design standard requirement along with Mill Standard 1316 for Fuze design safety requirement, there's a lot of overlap and commonality. So we're trying to keep pace with the changes that are occurring in 1901 to make sure that they are also captured in 1316. The third document that's currently in progress is a new Joint Ordnance Test Procedure, JOTP. Does not have a number qualification just yet, but it is addressing inline initiator qualification, and it actually leverages from the existing MIL DTL 23659, which is a general qualification standard for all initiators. We're just extracting the inline initiator element from it and updating it. Next slide, please. The next document I'd like to highlight is JOTP 055. That one is a relatively new document. It is the criteria for submunition advanced features to meet the 2017 DoD policy on cluster munition. It really what this JOTP goes after is in 2017, DoD established a policy on what the DoD will acquire in terms of cluster munition. The technical specifications of that policy list 3 criteria. 2 out of the 3 are pretty straightforward. But the third criteria, when the Fuze technical community got wind of this document, we started having some concerns. How would the technical community, how would our industry partners interpret those requirements that policy set forward? So there was an initiative, we coordinated with OSD policymakers on cluster munition for clarification, as well as permission in establishing this document. We received that permission and we began development of this document. And I like to term it as the COVID document because we began this in September of 2020. So just like Mrs. Miles Patrick had mentioned, there are advantages of having some virtual working groups. And we started this out by having all virtual meetings. We've had our first hybrid FESWIG meeting this past February, where we had certain folks in person and some virtual, where we really hashed out the rest of this document in the comments so that we can start getting it ready for promulgation. And I've been told that it should be posted tomorrow on DoD Assist under drafts for review. So we began this document, which is key in ensuring that what OSD set forth in terms of cluster munition policy in acquiring cluster munitions, how we can satisfy that particular paragraph within policy, establishing design criteria so that industry partners can understand and execute it, as well as establishing test and evaluation criteria so we can ensure that we're meeting those requirements as intended. So we've coordinated with OSD. We've developed this document almost 90% virtual, and it's hitting DoD Assist under draft review to begin comments. So that's, again, if you're starting to consider the list of nominees for next year's award winners, that one sounds good. Shameless plug, I apologize. And so the last one really talks to the emerging technology on unmanned systems. So again, this is a new joint ordnance test procedure, no number affiliated just yet, but it's really talking to how do we address unique fusing requirements intended for unmanned platforms? How do you recover those assets safely? So that one is definitely continuing to be worked within our working groups. Next slide, please. And so our next FESWIC meeting, again, will be hybrid in person and virtual. This will be our 105th FESWIC, and it's scheduled for the end of this September. We will actually be meeting at the OSD's Defense Microelectronics Activity, DMEA. We've actually met there once before. We're actually meeting there again because we want to leverage their knowledge base. There are challenges in the microelectronics world within logic devices, specifically ASICs and FPGAs, and how they relate to fuse safety. So we've met with them once before. We want to definitely leverage and take advantage of their knowledge base and enhance those as we advance our own standardization documents within FESWIC. So that collaboration there of where we're meeting with FESWIC is really, to the point of how we are engaging not just within our immediate community of fuse and initiation experts, but as well as those other areas that we definitely need our expertise in. Next slide, please. So the next set of slides will be discussed by Mr. DiGiacomo. Tony, are you out there? Are you in virtual land here?
I've just unmuted myself. Can you hear me?
Tony, I think if you can go a little louder, you're coming in a little bit soft.
Okay. Let me try to adjust.
Okay.
Is it better?
A little bit.
Not sure why. Not sure what else I can do here. I've raised my volume and holding the microphone closer.
Okay.
Is it any better?
A little bit. I think we can proceed.
Okay. All right. Well, good afternoon, everyone. I am the last presenter, so I'll try not to take up too much time, but thank you for having us. As Sandy said before, we're in the same office, participating in the same activities with different functions. We have different functions within the activities. Next slide, please. So as was mentioned earlier, the NATO standardization portion of the FESWIG is under subgroup A. You see here a edited version of the org chart for NATO. We are under the AC 326 ammunition safety group under the CNAD. So under the ammunition safety group, we have 3 subgroups. You see that the subgroup A is actually divided into 2 groups. About 10 years ago, NATO decided that they had too many subgroups. They were trying to be more lean and efficient, and they reduced the number from 5 or 6 groups to 3. But when you mash groups together, sometimes they don't blend very well. So the subgroup A on energetic materials and the subgroup A on fusing and initiation systems, we are under one umbrella, but we meet separately because we have different products and different documents. We all cannot, it wouldn't be efficient to meet together. So we meet separately. But for NATO, it seems like it's one group, and they seem to be happy with that. Next slide, please. So under subgroup A, I chair the initiation systems team, and there is another chair for the energetics material team. We meet twice a year, and we work on documents for about a week at a time. So we meet from Monday to Friday, and we work on documents and trying to move forward with our standardization process. Next slide, please. So the way the documents are organized under the NATO is we have the STANAG, which is Standardization Agreement, that nations agree to follow and adopt. Under that, the STANAG is typically a very short document without any technical information. Under that STANAG, we have the Allied standards, which have the bulk of the standardization and requirements and testing requirements, design requirements, safety requirements, and so on. There are different under the STANAG. You see the STANREC, and these are documents that NATO has over the years decided if there are documents from industry or other nations that can be used as guidance, but they're not requirements that they must follow. They're more like recommendations. And so they've split the covering documents into two different sets. And then after the Allied standards, which I mentioned earlier, there's more detailed documents that go deeper into explaining or clarifying some of the information in the Allied standards. The definitions for all these are in the backup slides, and you'll have a chance to see them when you get the package. Next slide, please. So the objectives, we've heard interoperability many times today. We report, or I report as the chairman of the subgroup twice a year to the main group, which is the AC326 I mentioned earlier. And in June, we had our first meeting since the December of 2019. We met in person for the first time. And besides interoperability, NATO seems to be focusing on interchangeability as well. So that's it's been mentioned before, but now it seems NATO will be bringing that up to the forefront, interchangeability. They want to be able to take something from one country and use it directly by another country. So you may hear more about that in the future. We want to provide safety, as has been mentioned many times before, assessment tools for testing, give guidance and specifications for munitions designers, introduce safe, reliable munitions, and the transportation of these munitions between nations and between different transportation vehicles. All are under the main group that our three subgroups try to address. Next slide, please. So you see here some of the, I'm getting a message on my computer that they want to restart my computer. So I'm trying to avoid that, most unfortunately. Or is it at your end? No, it's at your end.
Yeah, Tony, this is Sandy. So it's
okay.
on our end over here, so stand by.
Okay. So anyway, I'll keep going until something happens or I'm stopped for some reason. So you see here the two lists between the NATO and the FESWIG. We try to keep the documents that we work on. Many times we bring the US documents to NATO and use it as a backbone to write the NATO documents. And there's a lot of similarity and there's a lot of exchanging of information between the two groups. are as you can see here, every U.S. document has a NATO version of it. And there are some documents actually which are only in NATO version. For example, the Standard 4369, which is inductive setting of large caliber munitions. There's the Standard 4593, which is in setting of guided large munitions. There are no U.S. Equivalents for that. So, over the years, there's always been a push to use common standards between NATO and the U.S. But as we review documents in FESWIG, and if we do bring them to NATO, there's always different perspectives in NATO, and NATO has some slightly different energetic materials or testing requirements. So there's always some little differences, but not really major differences. And many times at the Fuze board, at our Fuze board here in the US, we see some foreign fuses that come to us, and they are designed to Standard 4187, for example. And there's no issue with that because we are very familiar with the requirements, which are very similar to 1316. So that helps us to review those fuses and to feel that the NATO fuses are just as safe as US fuses. So you can see this for yourself here, the documents. I won't spend more time on it. Next slide, please. So in the last several years, we've not been able to meet in person. So we've been meeting using Teams as a tool for virtual meetings. And even though we've not been able to meet for 8 hours a day because of time differences between all the different nations involved, we've been able to accomplish some of the updates to important standards. The 4187, which is the equivalent of the MIL Standard 1316 for design of fusing, has been promulgated in June. The Standard 4560, which is the characterization of electro-explosive devices, was approved for promulgation as well. The 4368, which is equivalent to the MIL Standard 1901 for rocket motor ignition, we plan to start working on that now that the FESWIG has completed, or the 1901 was close to completing it. We can bring it to NATO and see what we can take from it in order to keep our commonality and interoperability at a high level. Occasionally, we get from our main group, we get tasks for considering new STANAGs. And one we got recently was to look at countermeasure devices, aircraft pyrotechnic countermeasure devices. There seems to be a lot of concern that these devices are not well controlled, not well tested, and there have been some accidents which have caused nations to appeal to our main group to see if we can write a document that can make these devices safer by standardizing design and testing. So we're starting to look at that now. The 4809, as Sandy mentioned earlier, we in the U.S. we have the remote control for Fuze fuses used on unpiloted vehicles, whether they be land, sea, or air. So we're starting to look at that at NATO as well, and we'll have a document similar to what we're working on in the U.S. And so these are some of the tasks and the work that we've been doing for the last several years, reaching promulgation for some standards, and we're getting close on some of the other standards. Again, keeping close to what the FESWIG is doing and trying to share as much information as we can. Our next meeting will be our first in-person meeting that we've planned since the COVID 19 issue. And we'll have it in Canada, Ottawa, Canada, on September 19th to the 23rd. So we look forward to seeing everyone in person again. Next slide, please. So the key takeaways, again, it's working under the Joint Standardization Board and FESWIG for fusing and initiation systems. We try to standardize as much as we can, taking into account new technologies and promoting interchangeability and interoperability, making munitions safe so that when soldiers handle foreign munitions, at least within the NATO umbrella, they can feel that those munitions are just as safe as US munitions. And we have heard about non-NATO munitions being evaluated by some of our experts, and I can tell you they're not very safe. They work, but sometimes they work when they shouldn't. So it's very important to keep these standards updated and to make sure that they are used in any munition used by our forces within NATO and within the US. So that's, is there anything else after this? Questions? I think that's all I have. And if there are any questions for me or Sandy, we'll try to address them. Thank you.
That was great. Thank you so much, Tony. Yes, let's. We've got a few minutes left. If we could just open it up to the floor of any questions of any of the JSBs. Michael, you want to take it over from here? I can't see the audience, so.
Any questions online? And none in the audience? Oh, we have one.
Yeah, I'll be quick. There are 5 joint boards, and it would seem like there's a whole lot more than that in joint activity. Why only these 5? Why aren't there more boards created? Is it the complexity or just the uniqueness of these particular 5 units?
Lloyd, could you hear that question?
Yeah, I got it. So the Joint Standardization Board concept came about in 2006. Every one of the current JSBs were created in 2006. So it's, and as I've said, and it's in and it's a coalition of the willing. It's very difficult to enforce standardization from standardization office. As a former standardization executive used to say, policy drives standardization. Standardization does not drive policy. And I say that a lot at the JSPs because if you need teeth, you need members, you need buy-in by the services. You need command policy that comes down and implements standardization. And we're there to help. We have the infrastructure. We know the decentralized standardization community. But as far as other boards, it requires membership, it requires a joint membership, requires a problem and a POAM. And so we have on our website the method on how to begin that. I've had a few folks come to us at DSPO asking about starting a JSB, and the few times it's happened, twice, it's been all one service. And the purpose of JSB is Joint Standardization Board. If one service can't get together and solve problems, we're not going to be able to do it for them as a JSB because it's a one service thing. So, but it's a good question. We have it on our website on how to do it. If there's other interest, please, my contact information is there, and you can reach out and do it. And that's really just the way the history went there. There are there's many joint boards, but not joint standardization boards. Over.
And they're an option. They're not a requirement. Right? We have a DSP governance structure through which vast majority of our documents are maintained and non-government standards adopted. But if there's a need, absolutely reach out to us, and we'll look into chartering another board.